If there's not enough potassium in the system stagnates. The nitrates accumulate, the plant stays rank green, potassium, and low on boron. This is not a nitrogen problem. This is an imbalance between potassium and boron. Anytime your boron's low, you're losing yield. So we really have to pay attention to that relationship. One particularly is this one here. This is how the plant basically moves photosynthetates through the plant and kind of how potassium plays a role. Potassium and nitrogen have to marry up at the root surface of 1-to-1. It translocates up that xylem, up into the plant. The nitrates break off to produce the proteins, amino acids, this sort of thing. And the potassium picks up the photosynthetates from that leaf, loads it into the phloem, and redistributes it through the plant down through that phloem. If there's not enough potassium in the system stagnates. The nitrates accumulate, the plant stays rank green and doesn't do anything because there's not enough potassium to empty the warehouse. So we need to understand that and understand that this process works this way. The other thing too, and this is something we'll talk about here, is boron plays a major role in maintaining the structure of that phloem. If something disrupts the phloem, then I can't move the photosynthetates away from that tissue, and again the system stalls or stands still. When you look at boron in its maintenance of that phloem, you can see on the left-hand side here a well-designed, well-developed phloem with good, decent boron levels. On the right-hand side, you see disruption of the cells in the phloem and just not a good conduit to move things, and that's because of boron deficiency. Anytime your boron's low, you're losing yield. So we really have to pay attention to that relationship on keeping this crop moving forward, because it is very important. We look at nitrates in plant. This happens to be a potato crop. This is a crop where a consultant was talking to me and said, I don't know what I did wrong. My nitrates are accumulating in this plant. I didn't put excess nitrogen on. It didn't rain. What's happening here? Well, I said, go back and look at your earlier tissue samples. Right from the start, you're low in potassium and low on boron. This is not a nitrogen problem. This is an imbalance between potassium and boron. The plant cannot use nitrogen effectively. So we need to understand these relationships when we're managing a crop, because we have a tendency to knee-jerk with nitrogen and just say it was too much or too little. In this particular case, if this grower was to stop using nitrogen on this crop and not address the potassium-boron condition, that field would likely open up to verticillium and just be a real problem. So make sure we're addressing it and we understand the physiology and the relationship between these nutrients before you become reactionary. The biggest problem I have in Western Canada is the fact that we're afraid of boron. I've had many cases where growers have said they got everything right. This happens to be a field where the growers thought everything was perfect. Great year, things were going great. I walked in off the headland because they dared me to find a deficiency. First tissue I pulled, I found a boron deficient leaf. And again, in a potato crop, we need to be over 30 part per million to get rid of this type of thing. Again, this crop is losing yield because my phloem is going to be disrupted. And I took this back to the lab. It came in at 27 part per million. So again, understand what the critical range is. Don't leave it to guess. We need to know. And there's too many people out there telling us that boron is not important. And the more research we do, the better yields we have is from using boron levels at the level we're talking about. Darren's talking about soil health. We've got lots of research now telling us that our microbial activity is very much influenced by boron application. In this particular case, it's not crop specific. It's saying the best microbial activity comes from a field that has an application of 3 to 4 pounds of actual boron per year to keep these organisms healthy. Not just for the plant. Plant needs certain levels of boron in the plant to do what it's supposed to do. But if we want to have healthy biologicals in our soil, we got to feed that field some boron. So with that, I'll shut up.
I always love listening to Greg. It's just like a major download from a mothership of agronomy that most of us can only dream of, obtaining half of the information. But Darren, when you listen to all that in your soil health program and your foliar program, what's sticking out to you?
Well, I think that In my experience, I mean, it's not everybody, but we have this dependence on nitrogen, phosphorus, and maybe in Saskatchewan, not we don't always think we have lots of potassium in the ground, and sometimes we think we have lots of sulfur as well, and we don't think of the micros like the borons and the magnesiums and the zincs and all that kind of stuff, and they're just as critical. And sometimes we can't get it, just someone to um, think about this and apply these micronutrients. But it's always, nitrogen and phosphorus and, sulfur. But we have to look at everything, and that's what a soil test will tell you. But that's also what a tissue test will tell you. I mean, are we needing more of these? And like I say, I think there's lots of yield that's left on the table that these farmers could have if we start looking at these other micronutrients and doing these tests because they will tell you. And I mean, I don't know if there's an agronomist out there that hasn't been on the A&L site. I mean, we've learned from it. There's so much information on that site. It is so well done that all this information is there. But I just think it gets overlooked too many times. And we're always looking for this new other thing to get yield. But yet it's because we're lacking something in the crops.
Well, the issue we have is that it's not easy to figure out um, what's going on. There's so many environmental impacts on the crops we're growing. Yes, you have lots of potassium, but a lot of that potassium is not available because your base saturation is so low. Weather permitting,